So we want to review difference of squares. So we have this example that we're motivated by. And it says, what does the instruction say? What do I want to do with this?
Factor difference squares?
Yeah, probably factor. So they said factor, and they told me like, hey dude, you might want to note that's difference of squares, right?
So we have a two
Okay.
X
Yes.
and an X, right?
So I got, wait, difference of squares is when I've got like something squared minus something else squared, right? Okay, so what's special about this form? There aren't any cross terms, right? There aren't any triangle times squares in here, which we might remember means that we multiplied two conjugates together. So the thing that you should remember about difference of squares is that you can factor something that looks like this into something that looks like this. So this is the thing that should go in your head for difference of squares. Okay, with that in my head, how do I want to, let me see, can I apply that to this?
Yeah.
Okay, so I'm kind of looking at this guy and I'm thinking this is x squared, right? That's a really dumb thought. When I look at 4y squared, what is that squared though? Okay, that's 2y squared, right? Okay, so I can factor this thing then as
X plus 2y.
okay, so this is like thinking, so x is the square over there, and the triangle is,
X minus.
it's a triangle. If this is 2y squared, the triangle is
X minus 2y?
2y. The minus is in the form, right? That minus is already in there. So I'm just looking at this and I'm seeing, okay, this is something squared minus something squared. So the first something is an x and the second something is a 2y. And so that factors into the first something plus the second something times the first something minus the second something. You see that? It's really all there is in difference of squares. It gets a little bit tough sometimes to recognize,
Yeah.
right? You want to try another one?
Sure. 36x squared minus 25y squared.
Okay, cool. All right, so same instructions, right? Okay, so I need to think about this as something squared minus something else squared. What are the somethings?
6 and
So 6x and 5y, right? Okay, so now I can factor this using my rule into something with a plus and something with a minus. What are they? Yeah, 6x and 5y. So 6x plus 5y and 6x minus 5y. Okay?
And when this is like factor of perfect square trinomials, can we, that would be like the AC method, but you couldn't use like quadratic for those, could you?
If you have them set equal to 0, you can solve PSTs with, so an equation where you have a PST equals 0. You can certainly solve that using the quadratic formula. It's going to tend to be easier to factor it,
Okay.
but it's not necessarily the only way to do it, right?
Alright.
You might pay a little price for not noticing a PST, which is that you end up using the quadratic formula on something that was pretty easy to start with.
Okay.
Same with difference of squares, right? If I've got a difference of squares set equal to 0, like this guy, these aren't great examples because these have both x's and y's in them, right? You guys see that? But if I had something like 36x squared minus 25 is equal to 0. Right, can I use the quadratic formula on this?
Wouldn't you need
Good.
another-
Yeah, sure, man. I mean, A is something, B is something, and C is something. What are they?
36.
36 and
Negative 25, 0.
negative 25 for this one and 0 for that one. Right, there aren't any x's. The negative 25 doesn't have an x on it, so it's the C term, right? So, can I plug this into the quadratic formula? Yeah, it'll fit. Is it a good idea? Hell no.
Wait,
Right.
you said the C term would be negative 25 because why?
Because there's no x on it.
Okay.
That form, right, the A, B, and C, those go with ax squared plus bx plus C
Okay.
equals 0,
I got you.
right?
Yeah.
So the b is attached to an x.
Okay.
So could I fit this in the quadratic formula? Yeah. Is it going to be a great idea? No, because the easy way to solve is to either notice difference of squares and factor, or add that 25 to the other side. Got 36x squared is 25, and then run extraction of roots on this, right? Which in this case is going to amount to a really easy divide by 36 and then take the plus minus square root of the result. You guys see that? You want to finish that off, or are you good doing that? Good? Okay.